Chapter 14, Number 30. A meteor that explodes in the atmosphere creates infrasound waves that travel multiple times around the globe. On February 15, 2013, the Chelyabinsk meteor produced infrasound waves with a wavelength of 6.4 kilometers that propagated 8840 kilometers in 8.43 hours. What was the frequency of these waves? So we're going to basically go back to two things. We're going to say the velocity is definitely delta x over delta t, and that's 8840 kilometers over 8.43 hours. And then we want to make sure we convert these to their appropriate things. So we'll say, well, there are 1,000 meters per kilometer, and there are 3,600 seconds per hour. That's the conversion, 60 minutes per hour times 60 seconds per minute. And so we end up with a speed of 287.87 meters per second, which is really 288 meters per second based on our sig figs. All right, we only have, I guess, 3 sig figs right there. And then part B, not really part B, but the next part is that the velocity is also lambda times f. So f is the velocity over the wavelength, which is 288 meters per second over 6.4 kilometers. And again, we're going to say times 1,000 meters per kilometer. I actually suspected that conversion ended up being redundant. If I hadn't done it, it would have been okay, but because we've been kilometers and kilometers, but that's fine. So 288 over 6.4 times 1,000, and we get 0.045 hertz. This is well below the 20 hertz for the edge of sound, so it is definitely infrasound. Also notice that, in my opinion, incorrectly, Walker puts an extra 0 here, but we only have, for this part, we only have 2 sig figs, so really we should only have 2 sig figs at the end. Anyway, there we go.